Hello everyone and welcome back. In the last video we talked about estimating the population proportion using an interval of values which are called confidence intervals. In this video we're going to talk about how we interpret confidence intervals and what the level of confidence actually means. So what exactly do we mean when we say that we are 95% confident that our interval contains the true proportion? Well, what we mean is that 95% of samples of this size will produce confidence intervals that capture the true proportion. And so if we were to repeatedly take random samples of the same size and then calculate the confidence interval for each of those samples, then we would expect that 95% of those intervals will capture the true proportion. The confidence level is the success rate of the method which produces confidence intervals that capture the true parameter. And so to illustrate what we have just discussed, let's consider taking 20 random samples and creating 20 confidence intervals. So in the following graph, each red dot represents a sample proportion, and the green horizontal line represents the true population proportion. Now notice that some of the confidence interval will capture the true proportion, while others will not capture the true proportion. And so the confidence level specifies the percentage of confidence intervals which will capture the true proportion. So now let's take a look at another example for finding confidence intervals. Suppose that for a school project, a student randomly sampled 182 other students at a university to determine if the majority of students were in favor of a proposal for a new cafeteria. The student found that 75 were in favor of the proposal. So let's find a 95% confidence interval for P, which is the proportion of students that are in favor of the proposal. So here our sample size is 182 students. And to find our confidence interval, we need to look for the sample proportion, which is our estimate. And this is the proportion of our sample that are in favor, which is 75 out of 182 students. And this will be approximately 0.41208. Next, we need to find our critical value. For 95% confidence, the critical value is 1.96. And the last thing we need is to calculate the standard error, which is the square root of p hat times 1 minus p hat all over n. So we have the square root of 0.41208 times 1 minus 0.41208, all divided by 182. And the standard error will be approximately 0.03648. And now we're ready to find our confidence interval. So the confidence interval is our estimate plus or minus the critical value times the standard error. So we have 0.41208 plus or minus 1.96 times 0.03648. So that is 0.41208 plus or minus a margin of error of 0.03648. 7151. So if we take 0.41208 and subtract the margin of error, we get 0.341, rounding to 3 decimal places. And if we take 0.41208 and add the margin of error, we get 0.484. So what we can say is that we are 95% confident that the true proportion of students in favor of the proposal is between 0.341 and 0.484. So now let's find a 99% confidence interval for P. Now we did most of the calculations in part A. The only thing that changes is the critical value. So we found the sample proportion to be 0.41208 and the standard error was 0.03648. Now the critical value for 99% confidence is 2.575. So now we can calculate our confidence interval. So we have 0.41208 plus or minus 2.575 times 0.03648. So that is 0.41208 plus or minus a margin of error of 0.09394. And so that will give us our interval, which is 0.318 to 0.506. And so what we can say is that we are 99% confident that the true proportion is between 0.318 and 0.506. So now let's compare the 95% and the 99% confidence intervals that we have just found. What do we notice about the length of the interval when we want to have a higher level of confidence? If we want to be more confident, then does the interval become wider or narrower? To be more confident that our interval will capture the true proportion, then we need to have a wider interval. The margin of error needs to be larger in order for the interval to be more likely to capture the true proportion, which will create a wider confidence interval. So now let's suppose that the student had sampled 364 students instead and found that 148 were in favor of the proposal. Let's find a 95% confidence interval for P. So the sample proportion is now going to be 148 out of 364, which will be approximately 0.40659. Our sample size is 364. For 95% confidence, our critical value is 1.96. And now we can calculate the standard error, which is the square root of p hat times 1 minus p hat all over n. So we have the square root of 0.40659 times 1 minus 0.40659, all divided by 364. And this will be approximately 0.02574. So now we can calculate our confidence interval. So we have 0.40659 plus or minus 1.96 times 0.02574. This will be 0.40659 plus or minus a margin of error of 0.05046. And so our interval is from 0.356 to 0.457. And so we say that we are 95% confident that the true proportion is between 0.356 and 0.457. So now let's compare the 95% confidence interval from part A and the 95% confidence interval that we just found. What do we notice about the confidence interval when we take a larger sample size with the same level of confidence? Well, generally, when we have a larger sample size, then the confidence interval will get narrower with the same level of confidence, and assuming that it has a similar sample proportion. And this is due to the margin of error formula. When we calculate the standard error, it is inversely proportional to the square root of the sample size. So as we increase our sample size, then the standard error will generally decrease, which will effectively decrease the margin of error. So this will conclude our lesson for this video. In the next video, we will talk about an important part of planning a study, which is choosing the right sample size. And I'll see you then.